Okay, I know what you're thinking. Quantum computers? Sounds complicated. Probably a bunch of scientists in lab coats doing math with cats in boxes. And you're not totally wrong. But what if I told you these weird little machines, built on the laws of quantum physics, could break every encryption we use today, cure diseases, revolutionize energy, and even predict the weather better than your favorite app? Yeah, this isn't sci-fi. It's already happening. So today, I'm breaking down quantum computers in plain English. No fluff, no jargon, and why they might be the biggest shift in tech since computers were invented. What is a quantum computer, really? Let's start here. Your regular computer, phone, laptop, smart fridge that judges your midnight snacks, uses bits. Bits are either a 0 or a 1. That's it. Everything from Netflix to TikTok is made from millions of those. Now enter quantum computers. They don't use bits, they use qubits, short for quantum bits. Here's where it gets weird, in a good way. Qubits can be 0, 1, or both at the same time. That's called superposition. Imagine flipping a coin. A normal bit is like heads or tails. A qubit is like the coin spinning in midair, existing in both states until you catch it. That's already cool. But wait, there's more. There's also something called entanglement. It's when two qubits become so linked, you can't describe one without the other, even if they're across the room, or the planet. Einstein literally called it spooky action at a distance. Put that together and quantum computers can explore a ridiculous number of why classical computers can't compete. Here's the thing. Regular computers are fast. Quantum computers are another species. Let's say you're trying to unlock a combination with 100 digits. A regular computer tries one combo at a time. A quantum computer? It explores all combos simultaneously. That's why governments, Google, IBM, and startups you've never heard of are all racing to build these machines. And it's not just for fun. They're chasing problems that are practically unsolvable today. Simulating complex molecules for drug discovery, optimizing global shipping routes, modeling financial markets to prevent crashes, cracking current encryption in minutes. That last one? We'll talk about that in a second. And yeah, it's terrifying. Okay, but can I play Minecraft on one? So, should you throw out your laptop and wait for a quantum MacBook? Nope. Quantum computers won't replace your current computer. They're not built for browsing YouTube or editing videos. They're specialists, not generalists. Think of them like a telescope. You wouldn't use a telescope to toast bread, but for looking at stars. It's unmatched. Quantum computers solve certain problems that are impossible or take a million years on today's machines. But for scrolling Instagram, you're good with what you've got. Real-world examples, not hype. All right, time to get real. What's actually happening right now? Drug development. Quantum computers can simulate how atoms interact, helping scientists test new drugs way faster and without animal testing. Battery breakthroughs. Companies like Volkswagen and Daimler are using quantum simulations to design better EV batteries. Climate modeling. Quantum machines could process more variables than classical ones, giving us more accurate climate forecasts, like actual predictions, not maybe cloudy, maybe a tornado. Finance. Some banks are using quantum optimization to simulate risk across thousands of variables. Wall Street is watching this like a hawk. Even agriculture is in on it. Think quantum fertilizer formulas, weather-tied crop predictions, and new compounds to replace pesticides. And this isn't coming soon hype. IBM, Google, D-Wave, and Rigetti have working prototypes. Some you can even access online. The dark side. Encryption and chaos. Here's where things get dicey. Almost all online security today, banking, passwords, messaging apps, relies on encryption that would take thousands of years to crack with a regular computer. A powerful quantum computer could do it in minutes. It's called Shor's algorithm, and it's real. It's just that no one has enough stable qubits to run it yet. But when they do, boom! Our current security system becomes Swiss cheese. That's why there's now a global race to build quantum-proof encryption, also called post-quantum cryptography. Yes, it's as dramatic as it sounds. Why it's so hard to build one? If this tech is so powerful, why don't we all have one? Because qubits are divas. They need to be kept at temperatures colder than outer space, can be ruined by the tiniest noise or vibration, and tend to fall apart, called decoherence, in microseconds. It's like building a computer out of bubbles, inside a volcano, during a whispering contest. Scientists are using lasers, superconductors, ion traps, and diamond vacancies to try to stabilize qubits. Each approach has trade-offs, and we're still figuring out what works best. It's not impossible, just insanely hard. But progress is picking up fast. So yeah, quantum computers are real. They're weird. They break rules. And they will change everything from medicine to national security to how we understand the universe. But we're still in the early days, like room-sized computer in the 1950s early. And just like classical computers reshaped the world, quantum ones are quietly preparing to do the same, just with more particles, less certainty, and a lot more quantum weirdness. If you made it this far, congrats! You now understand more about quantum computing than most people. You're basically a quantum wizard. Use your powers wisely. Like, share, or comment if your brain didn't melt. And let me know if you want a deep dive into how quantum encryption actually works, or a video tour of a real quantum lab. Till next time, stay curious.